Now, sig figs in math. So you paid for it. You should be a little ticked off that some dude didn't do his rounding right. And they screwed up with a Patriot missile. That was in Saudi Arabia, though. But it's probably our missile. Don't they buy all of our stuff? So it's probably one of us that screwed up. Government Accounting Office, GAO report. So the watchdogs of government. That's where that was from. Okay. Conventional rules with sig figs, significant figures, and math. When you're adding in or subtracting, report the answer to. Now there's three choices up there. There's three choices. Danielle, okay, let's go through them maybe first. When adding or subtracting, report the answer to. The same number of sig figs is the measurement with the least number of sig figs. So what I guess that would mean is you look through them all, find out the one that has the least number of sig figs, report your answer to that one. Option B, the same number of sig figs as the measurement with the most number of sig figs. Option C, the least decimal place out of all the measurements, regardless of the number of sig figs in the measurement. Sounds like you could have a really huge number, right? But report it to the, the smallest decimal place that's up there. It could be the tenths place, the hundredths place, whichever one is the least resolution, or the ones place if there is no decimal. Right? Three options. 33.33% chance. She's going with A. Is that your final answer? Yeah, what's the other option? You can call a friend or something?
Phone a friend.
That taxi, isn't that a taxi show? I don't know. She says A. Agree? Cash Cab. I love that show. I don't know how people know that stuff, right? You gather three people in my family in that taxi, we can't answer one question. Not one. So I don't know where these people are. I don't know. Anyway. A. B. C. Man, you guys do not go into Cash Cab. All of you are wrong. The answer is C. Isn't that weird? Isn't that strange? Adding or doesn't matter how many sig figs there are. You report to the, and I think if you think about it this way.
Aren't A and C kind of similar? Like you pick the smallest one and the least amount of sig figs?
No, in A they're saying when you're adding and subtracting, 2,321.8, and then adding and subtracting, so let's say plus 6, okay? According to the first one, if you go by A, the number of sig figs is the measurement with the least number of sig figs. Okay, so you have to report your answer to one sig fig then, if you follow A. If you follow C, you do the math, report your answer to what? Yeah, which is going to be what? The tens, hundred thousands, 1,000s, hundreds, tenths. You know, this guy is to the tenths, but this guy is to the ones place. You have to report your answer to the ones place. So it would be 2327.8, round up 2327, right? No, 2328, right? Because if you do that in calculator generation, right? 2327.8. You have to report your answer to the ones place. That means that 7 is going to become an 8, 2328. Okay? And if you think about it, to me it kind of makes sense. If you pretend you know what the tool is. The tool is a meter stick. And like, if you add meter stick, meter stick, meter stick, right, 2321.8 meter sticks, so the 0.8 lines up, I guess it's only in the tenths place. This meter stick only has a line every 10 centimeters, right? And it lines up with the 8th one really well. And you add that to 6 meter sticks, well, that 2328 makes sense then. Because 2,321 plus 6 more, you know it. You didn't, that's all significant. It makes sense. To me, it works. It's the resolution is where you screw up. You can't all of a sudden, you're using a meter stick that had 10 centimeter divisions. You can't all of a sudden pretend it had 0.1 centimeter divisions or something, right? It's that resolution. The R word is what adding and subtracting is the resolution. And when I think of resolution, I'm thinking of this stuff. 0.03, you know, the tenths place, the hundredths place, right? The tenths, hundredths, thousandths, the 10,000ths. That's resolution. Or just the ones, or the tens, or the hundreds place. That's resolution. Just how many lines are there per unit? Okay. So the answer was C. When you're adding and subtracting. So how are you going to do this then? I don't know. Do it all on your calculator. I don't know. And then you try to figure out the sig figs later. That's what I do. 7.3 plus 0.0021 minus 0.03. Now, if you do all that in your calculator in one big swoop, I came out with 7.27. Yeah, thanks. 21. Now, hang on. Let's slow down a little bit. Should I have been doing some rounding in here before? Yeah, you don't do any rounding. And that goes for all calculations. No rounding to the very end. Okay, so this is the whole answer in all its glory. You'd report your answer to what decimal place then? Or to what place? The tenths. This guy has the worst resolution. So you can't pretend you can't report an answer to the hundredths place because the guy's ruler only went 10 centimeter divisions, for example. You can't pretend. So you have to report to the tenths place. So now there's a bunch of ways to report your answer here now. You could just write 7.3. Draw a box around it. That's my answer. You could, does anyone see the book? What do they do with these little underlying things? They put it under the last digit that's significant. That's another shorthand way of doing it. So I don't know if does the book do that? I think the book does that. You'll see it. You haven't done the homework yet. Okay. But I think this is the best way. Okay. Okay. Have to do this mess on your calculator. 246. Okay. All right. Report it to what place? Hundredths. All right. Hundredths. 229.04. Now, someone, I don't know, Kat or someone came by and asked about this rounding thing. And I'm going to wait till we encounter the problem with this rounding. Remember, because we always see a 5 we were supposed to round up. Okay, let's wait till we hit one, and then we'll talk about it. It'll make more sense. Okay, so good so far, right? Now we're just multiplying and dividing. Casey, same 3 choices. The first one. Does everybody agree? Yep. That's it. That's it. You go through the calculation, see the measurement that has the least number of sig, as long as you're just multiplying and dividing. You can't be adding and subtracting in there. It just has to be all total multiplication, total division. That's all you're doing. If you go through there, see which one has the least sig figs, report your answer to that guy. So in part A here, question A, Erica, how many sig figs are you going to report your answer to? Yeah, it's just going to be 2. Look through them all. And this guy only has 2. How many does, well, you know how many, this one has 3. How many does this one have? Yeah, 4. Okay, so you just do it all on your calculator, report it to 2 sig figs. it means, to me, it means scientific notation is the only way. How else could you do it?
I don't know.
Because I have 4, 1, 1, 3, 2.24. Because if you wrote 2 sig figs and you wrote 41, how many zeros is that? 3? You know, that isn't going to work because are these zeros significant or not? I mean, so that it's not clear and you're really playing with fire and you can't really do it. You'll have your missile will blow up. So 1, 2, 3, 4. I count the 4th place. And we said how many sig figs? That's 2, so 4.1.
Why do people use sig figs? Because that number does not seem anywhere close to the actual number is.
The reason why they use the sig figs is because if let's see, everything has, whatever you measure, they only have a certain resolution. It might be more complicated than actually having lines on the scale and you're actually reading it. It could be an actual little pressure dealie, and it's all electronic and it kicks out a little number all the time. But it's only going to kick out a certain resolution between numbers, even if there isn't a scale. So but you believe those numbers. If you get the right numbers and everything is working properly, little rockets and everything, and as complicated as it is, if the software's right and everything's right, all these numbers are true, you feed it good stuff comes out and it does what it's supposed to do. If you feed it something bad data, and then you don't get the right result. It ends up going this way instead of that way. What is bad data? Bad data is, okay, okay, you are a mannequin, and you can shoot a bullet that is roughly, you have this gun that shoots automatically, and you have it all set up, you know, it's all nice and stable, and it can shoot the same spot, but not perfectly every time. The radius might be like an inch, right? So the standard deviation is about an inch. So, okay, it's all set up. You're going to make this big TV show, right? And you're going to go stand in front of the TV, and I'm going to put this little quarter right here in my pocket, right? And the little gun's all lined, everything's all lined up, right? And see, just imagine how if someone said it's no longer an inch, it's more like 1.2 inches. See, if you screw up the bad data, you make things a lot worse. And an inch is a lot to think about. The problem is more the really tiny numbers where you can't even tell the difference, right? Like making something a 3 or a 9 or an 8 or just do a little rounding, so really tiny numbers. But if the size of the quarter was that small and that much depended on it, see how a little tiny difference can really make a huge mistake. To me, that's all resolution. So if this guy can only measure an inch, you can't pretend he can, if you didn't see the lines in between, you can't pretend he can do millimeters. You can't pretend he can do hundredths of an inch reproducibly and use this thing. I'm actually reading the length of this book. That's a lie. If you get in and put bad data in and that's a lie, you're going to get out with bad data. It's going to screw up everything. Reliability, I think. So, you pretty much have to use your imagination. But that guy wasn't imagination. I think people even got killed in that mess. Okay, good question. So see if you can knock these out. Now let's do this one at a time, because look at this one. There's plus minus in it. Let's do this one first. See if everybody gets the same answer. Let's do B together. See if everybody gets the same answer on it. How many sig figs do I have to report this answer to?
3.
Now, how are you comfortable? I mean, you're all right. If whoever said 3, most of you, I think, said 3. It's that one. How do you know it's 3? All you did is you move the decimal place over. You pretty much, in your head, I bet, what you're doing is you're writing it in scientific notation. Times 10 to the negative 3. See, and when you moved it over, these zeros are gone. But that one didn't disappear. All right, good. Okay, so 3 sig figs. That would be this guy right here. So you should have had 5.14 times 10 to the, is it 6? Thank you. Okay. Now if you're, and you're gonna, when you do C on your calculator, what would you do first? You do the stuff in the parentheses, right? I would too. So that doesn't change, except just keep track of the number of sig figs in your answer. And you have to apply, not rule 2, but you have to apply rule 1. So apply rule 1 to do this part. But keep track of the number of sig figs in your answer. And remember, you can't do any rounding to the end. So you need to write out everything, but keep track somehow of the number of sig figs there, however you want to do it. I think the book is doing it by writing little underscores. You can't do any rounding until the very end. So keep track of them. Not an easy one. Okay, let's see if we can get an answer before we go and work it out. So let's pick on Pablo. What did you get as an answer? What is it? He says negative 23. I don't know. We'll figure it out. Any other answers? Negative 23.04. Any other ones? I honestly don't know. We got to figure it out. Danielle, what'd you have? Negative 23. Okay. Okay. So how should we do this? You do the first part, the addition here. Everybody agrees with. I think that's your answer, right? Okay. Now let's put a little underscore to keep track of our sig figs. Underneath the 4. Exactly. Right? Okay. Now I multiplied these two guys together and I got this. But I know I have to do some subtracting. So I have to follow that least resolution idea. Whoever's got the worst resolution, I have to report my answer to that. I can't tell with sig fig, with scientific notation. I'm going to write it out with the 0.0, right? It'd be a lot easier for me to see it. So I'm going to rewrite that one as 0. How many zeros? 2. And then a 1, 0.21946. Okay. So I have that number minus 23.0423, and this guy's underlined. What do I underline in the 0.00121946 number?
The one, not one, the 1, 2, and the 1. That one, right? The one between the 2 and the 9.
Yeah. Let's go back. How many sig figs in the 53.02? 4. 4 sig figs. How many sig figs in the 2.30 times 10 to the negative 5? It's 3, because in scientific notation it's easier. Just count up everything. So that one's 3. So I have to report my answer in this part to how many sig figs? 3, because that's the rule. Multiplying and dividing, report to the least number of sig figs. Okay, so what number do I underline up here? Yeah, that dude right there is the one I have to underline. Has to be 3 sig figs. So I underline him. Okay, now when I do this subtraction thing, where do I report my answer? To what place? The hundredths, right? Because he's way too far. He's tens, hundreds, thousands, 100,000. No way, man. This guy's only to the hundredths. So you have to report your answer to the hundredths place. But again, you don't do any rounding to the very end. So okay. Oh, it is a negative, isn't it? Negative 23. I'll be right with you. Negative 23. I'm just going to write it all down here. 04108. And I can keep going, but we have to report it to the worst resolution. That's the hundredths place. That's the hundredths place. So negative 23.04. Wow, that's good if you got that.
Why is the second one?
Oh, why is the second one? Okay, so this number is the result of this multiplication, right? Of that. So how many sig figs? Now it's multiplying, so you have to report your answer to the measurement that has the least number of sig figs. So 53.02 has how many sig figs? Has 4, because that 0 is significant. You write that in scientific notation, that 0 did not disappear on you. 4 sig figs and 3 sig figs. So when you do this, you can only have 3 significant figures. So that's why we underlined the 1. Because if you write, if you write in scientific notation, and you'd have 1.21. 9%. That's the third digit. Okay. Good. Try this next one here. Don't do any rounding to the very end. If you're not sure how to do this, just ask. Miranda, what did you get as an answer? She says 5.3. Anybody else get 5.3? 5.3s? Anything different? All right. So when you did the first sum, 240.1 plus 28, you get 268.1. Where do I draw my little underline dude? Under the 8. Because look, he's to the ones place. So this guy has to be under the 8. Okay, and then I added the 0.0023 and the 50.2. I got 50.2023. Now what do I underline? The first two. The first two. Good. Okay. Now I have to divide these two numbers, and I'm going to report my answer to how many sig figs? How many? 3, right? I think they both have 3 sig. Yeah, they both have 3 sig figs. They both have 3 sig figs. Oh, so nobody's right. How many are in our answer? 2. You need 3 sig figs. Oh yeah, it keeps going. The final answer is 5.340392. All right, it keeps going. But 3 sig figs. Okay. 5.34. Makes sense? All right, here's some more questions. Kathleen, how many sig figs are in part A there? What would you say? She says 5. Everybody agree? Yeah, they're all good. In fact, if you wrote it in scientific notation, it'd be that number times 10 to the 0, right? Because it's already between 1 and 10. So she just counts up all the digits there. How about Amanda? No, Amanda's gone here. Right? Adriana. She's not here. She took the quiz later, too. Adrian. How many sig figs in B? Everybody agree? Yeah, right? Scientific notation if you don't believe them. Okay. C? Pedro. 3? Yep. I agree, too. Okay, now we're getting into some rounding stuff. Round each number as indicated. So go ahead and do that. Then I'll show you a problem. Okay. I like the science movies that, stick to science. The space show, not the rocket, the big spaceships going by. Do you hear anything? If you're sitting outside watching the spaceship go by, are you supposed to hear anything? No, right? There's no air, right? So you don't hear anything, right? There was a movie that took what's going to happen here into account. These guys worked in a bank. And the banking transactions happen all the time, but there's a rounding problem, and it's not fair. And they made millions of dollars on this. If you look at what I'm talking about is, let's see, where's the 5 one? D and E. Okay, D and E. So 2 sig figs. This guy, right? How do you round? Right, there's a 5 and E. Well, 3 sig figs. Oh, that's to 2 sig. I'm supposed to go here, right? A 5 is next. And it's not fair. Let me show you what's not fair. What are all the possible, what are all the possible numbers? Right, usually we want to round the 5, round it up all the time. Let's show you how that's not fair. 0, 1, 3, 2, 3, 4. Here's all the possible numbers. 6, 7, 8, 9. Right? Okay. We're used to saying if it's 5 or higher, we round up, right? Okay. 5 or higher, you round up. So, isn't that what we did? How did I figure this out? I saw this just before we came in here. It didn't. 5 or higher, we round up. Is that right? That is right. So that means 1, 2, 3, 4, 5. 1, 2, 3, 4. How did this not work? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Looks like it's working. I saw this 20 minutes ago. I don't see it now. There. Shoot. How come I can't see this now? 0, 1, 2, 3, 4, 5. It's 5 or higher, we round up. We're talking about this digit. What I'm trying to get at is this guy right here. If 5 or higher, we round up. Okay. Now, 5 or higher, round up. So what that means is that it's not you're biasing you're biasing things. If it's 5 or higher, you're always rounding up. Always. So 6, 7, 8, 9. Because remember, this is the important thing to catch, is that digit after it means nothing. It's insignificant. It's a random number. That's what the whole idea of significant figures is. After that last significant digit, everything is freaking random. So you're saying after 5, 6, 7, 8, 9, I'm always going to round up every single time. No, you need to make things random. You need to, because it's a random, those are random numbers back here. So what you need to do is, okay, the problem is a 5. I can't follow a strict rule. I need to look at this guy, I need to make it random. Sometimes I'm going to round up, sometimes I'm going to round down. The easiest way to do that is even and odd. So first I'm going to tell you the right way, even or odd. If this guy's even, you decide. I'm going to always round up. If this number's odd, I can always round down. Now again, when do you encounter this? I have to round to this digit right here. The next one's a 5. Well, I want to do the whole, 5 or higher, you always round up. No, you're biasing your data. So, because you're making a rule out of things that don't have any rules. They're random. So you have to make it random. You look at the digit after the 5, and you say, hey, he's even. Oh, what was my rule? Round up. It's up to you, but you got to stick with it. Right?
So whenever we're doing this on like a test or something, do we need to write our rule?
I'm not going to have it. It'll be too complicated. And if it's in there, I'm going to screw up. It could be a conceptual question, because you haven't had the analytical test yet. But I have some conceptual stuff, and then you have some problems.
In this case, would it be you round it up?
We have to make the rule. We have to make the rule. Let's make the rule. Even down. Odd up. So we're talking about the number after the 5. So, right? So I guess this is when rounding a 5. You look at the next digit. That way it makes it random. Okay? And those guys, they always did the rounding up or something. They were making I forget how it was, but it made sense at the time. Anyway, this is how you don't bias things. It sounds like a minor point, but I guess when you're talking about millions of rats in some laboratory, it might matter. Yeah, have a good weekend. Okay, so we should answer these. To 4 sig figs. Well, how did you answer A? 1.237. How about B? 1.238. C? 0.135. Well, I guess you say 0, I guess. And D, now following our rules. It's odd, so we're going to go up. So we would say 2.1. And E, now 0 isn't odd. 0 is even, right? It has to go even, odd, even, odd. Yeah, so 0 is even. We're going to round what again? Round down. So it'd be 2.00. I think in the reading, the book might have had a rule, but it's arbitrary. Just got to stick to it. Odd, even, or odd up, even down, or something. I don't know. Okay. Here's some more of these dudes. Write each answer with the correct number of digits. So we literally did the calculator stuff for you. What should I underline? What's the last digit that's... The first one? I hear the first one. Everybody agree? Yeah, that guy right there. 3.71. How about C? Have to have 2 sig figs, but how are you going to good? How are you going to report your answer? What would you say? Isn't that problematic? Right? Because you write 40, unless you put a little what in there? Put a little decimal point in there. Right? Otherwise, that's just our English language that's screwing us over. It's 40 miles. Well, I mean, it could be 41, it could be 38, right? It's just rough. Even though we meant 40. So you don't know. So you have to put a decimal point, or just write it in scientific notation. That's the best way. And everyone knows what you're talking about. Okay. We have 1 minute, and I'm not going to keep you over this time. Especially on a Friday. My gosh, I'd have a revolt. Oh, this isn't so bad. It's just multiplication and division, part D.